Hey guys, Mr. Yisley here. So we're on to lesson number 20, which is talking specifically about correlation and causation. And so we talked about correlation earlier in the chapter, and just a reminder on the definition, this is saying that there's a relationship between two pieces of information. So it's saying that, hey, these two things go together. So like in our lesson number 19, we talked about the amount of weeks a DVD was out and the sales that were happening of that DVD. Those things had a relationship to each other, right? Whereas causation, this new word, if you looked it up in your vocabulary, is talking about more specifically that relationship that exists. And so what it says in that is if there is a change in one of those pieces of information, so there's a change in how many weeks the DVDs had been out, then this directly causes the change to happen in the other piece of information. Not that the relationship exists, but that it really actually causes that to happen. And so, like, if we think back all the way back to lesson number 16, where we talked about those smoothies, and we talked about this relationship between the amount of sugar in grams and the amount of calories that were in it. The more sugar we poured into our smoothie, the more calories there were. That was a direct causation. The more of that sugar, more tablespoons you added into those smoothies of sugar, there was a direct cause to the calories increasing. And so that would be an example of causation. So what we're going to do here in these three examples on lesson number 20 is we're going to decide, all right, if there's a correlation that's likely in this situation. So is there a relationship between the two things? All right, and if there is, we're going to talk about it or explain, is there a causal relationship? All right, when one thing does something, does it exactly cause the other thing to do that? All right, so we need to make sure that we're doing a good job of recognizing just because there is a relationship doesn't mean that it's a causal relationship, all right? But if there is a relationship, we need to determine if that's a causal relationship. So let's take a look at three examples here that go through this. So in example A, it says time spent exercising and the number of calories burned, all right? So is there first a correlation, right, between the number or the time spent exercising, right, and that'd kind of be like your X, right? So if we were thinking about it in that terms, that'd be like your X, right? And the number of calories burned, that'd be like your Y. So if I were to spend 10 minutes exercising, what I need to decide is where would my calories burned be? If I spent no minutes, I'd burn no calories. If I spent 1 minute, I might burn 3 calories. If I spent 2 minutes, I'd probably burn a couple more calories, maybe 5 or 6, right? If I spent 10 minutes, I may be up to like 50 calories. So it's continuing to change. As X is increasing, the amount of minutes, all right, that I spend exercising is increasing. The number of calories burned is also increasing. So there is definitely, so when X and Y both increase, we've talked about that is a positive correlation. So I need to write that. There is a positive correlation between these things. There's a positive correlation. Now we've decided that, hey, there is definitely a relationship there, all right? It's a positive relationship in terms of every time X is increasing, Y is increasing. Now what I need to decide is there a causal relationship, all right? Is me exercising causing me to burn more calories? Well, definitely. If you know very little about the human body or about exercising, if you exercise, you will burn calories. That's how it works. You're putting your body under stress, which causes it to burn calories and to shed fat and to do all of these things. And so there is definitely a causal relationship there. So I would say something to the effect of there's a positive correlation and a causal relationship because they've asked us to explain our reasoning, because the more minutes I spend exercising, the more calories I burn. The more minutes I spend exercising causes me to burn more calories. So with these, when it comes to causal relationship, there's really no mathematical. It's really us putting information together that we know to be true in the real world. So we really have to think about those things. So let's take a look at example B then. I'd encourage you to try it on your own, then check your answer with mine. So example B says the number of banks and the population of a city, right? Well, number of banks, that would be like the X, and then the population of a city, that would be like our Y. So what we want to talk about here is, well, what's going on, all right? Does the number of banks and the population of a city, do they have a relationship? Well, if I think about it, and I've lived a couple of places in my life. I've lived in Tulsa, Oklahoma, which is close to 1 million people. Or 500,000 people, excuse me, and there are a lot of banks there, a lot of banks, right? I've also lived in a town of about 12,000 people, and there were a few banks, but definitely nowhere near the amount of banks. I've also lived here in Great Falls, which is 60,000 people, so that's kind of in between those two cities. And I would say there's more banks here than there were in the city of 12,000, but there's not as many banks here as there was in Tulsa, Oklahoma, a city of about 500,000. So I could say that there is definitely a relationship, all right? There's more people, we need more banks to distribute more money. So definitely I would say that there is a correlation taking place. Now, at any size, is it positive or negative? Well, more banks typically meant that there was a bigger population. So as X was increasing, the number of banks was increasing, so was the number of people in the city, according to the data that I've seen throughout my lifetime. So again, I would say there could be a positive correlation, right? Now, that is not necessarily always going to hold true. I'm just looking at my own life within that. There could be a positive correlation. All right. But what I need to decide is that a causal relationship? So if we were to just build a whole lot more banks here in Great Falls, does that mean the population of the city would grow in proportion to that, is what I should say, in proportion to that, right? So when I think about that, if I just went out and built 4 more banks, I'd have to have people to work in them, right? Well, we've got enough people in our town that need jobs, so we probably could fill the vast majority of the positions in those banks with people that already live here. Now, we may bring in a few people from outside of town to come here, or they may want to come here because of a position that they're looking to be in and work. But that doesn't necessarily, I'm not going to fill every one of those positions with new people from outside of our city, right? So I would say that though we may bring in a few new people, proportionately for the number of banks and the growth of the population, there's not really, I can't just build 4 banks and that's going to bring in 10,000 new people. Like, that's not how it's going to work. It may bring in 3 or 4 more new people, but on the whole, the population is going to stay the same in this city. So because building banks doesn't directly affect the population of the city, I would say there's no causal relationship. So there could be a positive correlation, but there is no causal relationship. And again, I have to explain why. And I would say because building banks does not increase populations of cities. All right, so example C, last one. I'd encourage you to try this one on your own and then check your answer with mine. So example C says, time spent playing video games and grade point average. So the time spent playing video games, that's like my X, and my grade point average, that's like my Y. Now, what I would say is we have to kind of think about this not in terms of how we want it to play out, but we need to think about it of how does it realistically play out. So time spent playing video games. So as my time is increasing, how does that affect my grade point average, right? Well, in order to maintain a perfect grade point average 4.0, I think all of us know that we have to study quite a bit. We've got to spend a lot of time not only paying attention in school on the whole, but also spending time outside of school, doing homework, studying for tests, all of that. So there's a specific amount of time outside of our daily routine in school that we need to spend to do really well. Well, I think we all could say that the less time we spend doing those things, studying, preparing, doing our homework, the more likely it is that our grade point average is starting to drop. I think we could all make that assumption and say that's fair. All right, so the farther from 4.0 we're going to be based on the amount of time that we're spending. Well, if we're spending time playing video games, and not that there's necessarily anything wrong playing video games, but the more time we start to spend, we start cutting into the amount of time that we can study, because there's only so much time during a day. You know, when you get home from school at 4 o'clock or whatever it is, you've only got, 6 or so hours to do things in, to study, to do your homework, to play video games, to eat dinner, all of that before you got to go to bed, right? And you've got to sleep. So if I'm spending an inordinate amount of time playing video games, right? Let's say of that 6 hours after school that I have before I have to go to bed, I've got an hour for eating, so really only about 5 hours. Maybe you've got some chores, so there's a half hour in itself, so you're down to 4.5 hours. If I'm spending 4 of those hours playing video games, that only leaves me 30 minutes to study. Well, the realisticness of studying for 30 minutes and maintaining a 4.0 GPA is not probably going to happen. You're going to need to spend more than 30 minutes a night to keep that 4.0 GPA. So I would say, based on that line of thinking, that our time spent playing video games does have a relationship to our grade point average, right? So I would say that there is a relationship. And the more time I spend playing video games, so as X increases, my grade point average is more likely, now it doesn't necessarily hold true in all cases, as we've seen on scatter plots, but it is more likely to start to trend downward from a 4.0. So I might go to a 3.9 or a 3.7 or whatever. So the more time I'm spending playing video games, the less time I have to study, which means my grade point average starts to drop. So as X increases, it's likely that Y would decrease. Well, as we've talked about, when we have X increasing but Y is decreasing, that's known as a negative correlation. So I would say there could be a negative correlation. And as well as we've explained here, a causal relationship. And then I need to explain why. Well, that's what we just talked about. Because the more time I spend playing video games, the less time I have to study, which affects my GPA. All right. Well, if you've got any additional questions about this idea of correlation and causation, please let me know. But otherwise, you should have what you need to continue on in the chapter.